Hello guys, today I'm going to talk about the 3D vectors from statics 1. I will show you that twice method of um, separating the components for the x, for the y, for the z axis, and I can remind you with you in high school uh, learned, and I will show you um, there is equations, and you can use uh, the equations, but you must know that what is theta z, what is phi, and uh, the force, of course, it's a given. Okay, I can say that uh, hmm, I had, J had, and K had. We have three unit vectors. Um they have got direction and they have got also magnitude. So we can call them I, J, K form, and uh, we can find sum up F1 and F2, so we can find the F resultant. So we can start. What is theta x? What is theta? What is phi and what is theta z? Theta z is the force, the angle between the force and z-axis. What's phi? Phi is the angle about, for example, here it's the door. So from the x-axis, the door opens 90 minus 25 degrees. So for F1 it is 65, and it is free. Okay. Also we have known theta z, and okay, we can start with F1, and it is free 65 degrees. What is theta z about F1? Theta z is from the z-axis and go to F1. So it is uh, if you look carefully, x and y axis here we have 90 degrees, and also we have 35 degrees. So 90 plus 35 degrees equal to 125 degrees. Okay, we found theta z. We can find phi. So it's easy to ask the question. Okay, F1 in the x-axis is equal to the magnitude of F1, 250 Newton, cross sin theta z sine 125 degrees, and also cosine phi, we found it 65 degrees. and it is I hat because we call the unit vector in the x-axis. It is I hat, so I can continue f1 in the y-axis. It is the magnitude of the f. It is 250 newtons cross sine theta z, sine theta z 125 cross sine phi and j hat. Okay. Also, we can find f1 and the z-axis. The magnitude of the f1, 250 Newton cross cosine theta z, theta z. It is 125 degrees and j hat. Nice. So we found f1's component. I, I started with f2 because it is easier than f2 because f2 is the easiest one because of knowing the angles, all of the angles, the axis. So I found it. F2. We can find F2's component with classical cosine formulas. For instance, we have the degree, the angle between Z and F2 axis. So we can use the method of cosine for the Newton cross cosine 60, and we know the in z-axis f2 it is k hat because it is positive direction in the z-axis. It's equal to f2 in the z-axis. So if we want to find in the y-axis, we have the angle between the y and f2, so we can find f2's component in the y with 40 Newton cross cosine 45 degrees, and it is y direction, so it must be plus, and it is j hat f2 and the y-axis. Okay, so the last one in the x-axis about f2, we have a large angle here, so I can find 400 Newton cross cosine 120. I hat is equal to f2 in the x-axis. We have from there minus, so we don't need to put an extra minus here because if we use the angle, the large from large, the cosine formula is minus, so it is wrong if I put here a minus. It is wrong. Don't do that. And we can find F2's component. So yes, and we must sum up in the I forms and J forms and K forms. F1 in the x-axis plus F2 in the x-axis is equal to F resultant force in the x-axis, F1 in the y, F2 in the y, F resultant in the y, F1 in the z, F2 in the z, and F resultant in the z. Okay, we can find them. And also it is just about calculating, and I can show you that last of the question. And here we can find the equations here, F resultant in the x-axis, F resultant and the y-axis, and the F resultant in the z-axis. We have known that because of calculating these equations, and we must sum up the I heads, J heads, and K heads. We can know that them. So we know F resultant in the x-axis, F resultant in the y-axis, F resultant in the z-axis. Okay, we have known the number of them, their magnitude. So we can find the magnitude of the resultant force with there's a square root F resultant in the x-axis square plus F resultant in the y-axis square plus F resultant in the z-axis square root. It is the magnitude of F resultant force. Okay, we found the magnitude of the resultant force. So the last things about the question: coordinate direction angles of the resultant force. We can find Schnell. Okay, if F resultant force cosine, I can call alpha is equal to Frx. Why? Because for example, we have a resultant force here. If there's a degree alpha between the resultant force and x-axis, r cross cosine alpha is equal to Fr in the x. It is correct, yes. So I can write the equation here, and F resultant's magnitude cross cosine theta is equal to F resultant in the y, and alpha is between F resultant and x-axis, theta, F ray, and in the y-axis, and also f magnitude of the f resultant cross cosine gamma is equal to force resultant in the z-axis. Also gamma is between f resultant and z-axis. So we found it from here, f resultant force, and we found it frz because here. So there's one equation that we don't know is cosine gamma, and there's one unknown, one equation, so we can find this and this and this, so we know anymore alpha, theta, and gamma. So there are direction angles of the F resultant. Okay, thanks for listening to me. Today I will finish the lecture. See you later.